Yeah, thank you very much for the introduction and the invitation. I'm really happy to be here. Also, some of the work I'm presenting was also done as part of NFDI for ING, NFDI for data science, or NFDI for energy, where I'm active. And the topic which I want to talk today about is how can we bridge between research data and AI and leverage also AI for research, which I think is one of the big questions we are facing today. And before I go into depth, let me maybe start a bit with a slide which I've stolen from Eric Schultes, who has described here nicely the interaction actually between the FAIR data principles and AI. Barend Mons also calls the FAIR principles ready for AI, or AI ready data basically. So, and when we have legacy data, we have to verify this data, make it adhering to the FAIR principles, which then results in data which has less noise, more trust, is more equitable. And then this kind of data can also help to realize fair AI and AI in general. So on the other hand, AI techniques can help in the verification process, for example, especially in helping to transform data according to the FAIR principles, so make it more findable, accessible, interoperable, reusable, for example, by mapping data to ontologies, and various other aspects of the verification process. And of course, also another aspect is that AI outputs data in fair formats, yeah, which also adhere to these FAIR principles. And so there are various interactions between fair data and fair AI, and I would like to also a bit talk about that. Yeah, if we look for if we ask a DALL-E or language model to create a vision model to create a figure about the relationship between FAIR principles and AI ready, something like this comes up, and you see that some of the aspects are correctly covered here, like making things accessible, findable, reusable. Already the spelling is not so much correct, and some things got quite mixed up here. And that's one of the key aspects or characteristics of a neural AI, that they don't really have this understanding of facts, or also the spelling of terms in a figure is something they struggle with. A similar example, when we look about text, you could ask ChatGPT a while ago to write a summary about the developments around a widely publicized scandal involving Professor Auer, and it would come up with a long story about data manipulation, plagiarism, misappropriation of research funds. So these are some of these characteristics of neural AI, that they don't really have this understanding of facts, but they're just combining information based on statistical patterns. And then when you have, for example, professor and scandal, exactly these terms, data manipulation, plagiarism, misappropriation of research funds, come up. And in that way, neural AI in a way resembles a little bit what Daniel Kahneman was calling thinking fast. Yeah, so intuitively, neural AI comes up with texts, with stories, with images, but it's not yet so good in thinking slow and really following a slow process. Of course, meanwhile, there are reasoning models which have incorporated these kind of reasoning that they first make a plan how to address a certain problem, divide it in small steps, and then go step by step. And the process, also this kind of chain of thought prompting facilitates that. But I think this only can solve a problem to a certain extent. And what my impression is that this neural AI models, machine intelligence, machine learning, pretty much resembles also how our human brains and human intelligence works. Yeah, so it maybe is like a super brain, of course, because it can cover basically has the background knowledge of the whole world. But of course, also mixed up and not really as factual information. And we also tend to make a lot of mistakes as humans. Yeah, we forget things, we mix up things, we have cannot memorize everything we want, and we have developed certain techniques, for example, looking up things in books, peer reviewing articles or books, curating databases, doing experiments, simulations. So we interact. We also use a lot of tools. If you have to do a complex calculation, we use a calculator instead of doing this just in our brain. And I think we need something similar in the world of AI. And this is called like neurosymbolic AI, where we combine neural models with symbolic knowledge representations. And the idea there is to use something like a knowledge graph or even more advanced types of knowledge graph, like cognitive knowledge graph, to represent information in such a way that both humans can interact with the information, but also machines. Um, and that basically also links between machine intelligence and human intelligence, putting such a knowledge graph in between. What is a knowledge graph? I guess most of you have heard about this concept already. So here on the right-hand side, you see an example excerpt from DBpedia, where you have entities, relationships, or also attributes describing these entities, like here the gender, the birth date, the family name, given name of Bob Dylan. And then you have relationships, for example, that Steve Jobs was a fan of Bob Dylan and lives in the US, was born in Duluth, and so on and so forth. And meanwhile, we have many of these kind of knowledge graphs. DBpedia is one of them. There's also Wikidata, which is integrated nicely into the Wikipedia ecosystem or Wikimedia ecosystem, but there are many other knowledge graphs covering many different domains like geographical knowledge, government, life sciences, linguistics, and so on and so forth. How is a knowledge graph different from other data representations? So a knowledge graph is a fabric of concept, class, property, definitions, relationships, and it uses a formal knowledge representation formalism, and that makes it, for example, different than property graphs, which don't typically have this. It's also quite holistic in a way that it covers multiple domains, multiple sources, different levels of granularity, like, for example, instance data from open sources, from private sources in a supply chain, or also completely closed data. And then we can have also derived aggregated data, schema data, metadata, taxonomies, links, and mappings. And in a way, I would say that knowledge graphs represent data in this unified formalism. So you have the ground truth, the raw data, the metadata, the vocabularies, the structure of the data, and that allows to use it also for AI applications in a consistent way. Meanwhile, there are a vast number of companies. So this slide is already 5 years old, and organizations building knowledge graphs to organize their data and to use knowledge graphs also for facilitating, for developing new digital applications and services. And meanwhile, I would say all larger companies have projects to build knowledge graphs to interlink knowledge from different sources and databases. Now the question is a little bit, how can we bring language models and knowledge graphs, so these neural models and knowledge graphs together? And both have actually quite complementary aspects. So language models are very good at text processing, at extraction, at summarization, translation, and generation of texts. While knowledge graphs are good at representing information and knowledge and also integrating and linking it. Language models have no concept of facts. They often and sometimes get some factual information right if it appeared significantly often in the training data, but often also not at all. And the knowledge in knowledge graphs, on the other hand, can be is human and machine readable, so it can be scrutinized and validated by us. Language models might have are like a black box and might have then hidden biases. Often they are also a bit superficial if they don't have specific training context or fine-tuning. Knowledge graphs, on the other hand, are very transparent. So the provenance, for example, where certain information comes from can be traced. And then there's, of course, also difference in computational resource requirements. These neural models often require more expensive infrastructure, but of course this over the years also reduces and is diminished. And from these kind of complementary aspects, I think there are a number of integration opportunities. So we can use knowledge graphs as a validated, trustworthy source. They can help organize and integrate knowledge from different sources. Also provide, on the other hand, input for enterprise or domain-specific training, fine-tuning. And the language models can then lower the entrance barrier to knowledge graphs, to ontologies, by helping us to create knowledge in the graph, by suggesting things, recommending, creating mappings, queries, and become like a front end for human interaction with the knowledge graph. And these different steps, how we can integrate, I have visualized here. So actually, 2-3 years ago, language models were used largely in isolation. So this is here the first stage, and they lacked factual knowledge. So many of the answers were actually wrong if it was about facts. And meanwhile, that's why language model process to retrieval augmented generation. So now questions which involve certain facts do, for example, a web search and retrieve certain context knowledge from web pages in order to augment answers or have a proper context. So then actually the language model is not really answering the question, it's more summarizing what it found on the web, for example, or in certain documents. Yeah. And another step is then use more structured information. So retrieval augmented generation uses documents, unstructured sources. The next step would then be to use more structured information sources such as databases or knowledge graphs for answering questions. And another step, which we also currently see in the development, is then agentic generation. And I think this will be a big step forward, when language models, generative AI is then using external tools such as reasoners, APIs, computation services, um, and finally, this might lead to artificial general intelligence, where you have then also self-reflection, goal setting. So, and now coming back a little bit to the area of research, yeah. So, typically I show this example here, how different domains evolved. There were mail order catalogs, street maps, phone books, encyclopedias, and they basically all got completely disrupted. And we have now digital tools, which are not just pseudo analog digitized copies of the analog artifacts, but really completely new business models, using also new services, using these new possibilities where you can zoom into the data, which are much more dynamic. The linking of data and services plays a big role, also crowdsourcing data curation. And if we now look at the area of scholarly communication, and this is extremely important, we spent 1.7 trillion US dollar on research and development worldwide. So a large amount of money and resources is invested in research and development. And my impression is that we don't use a large share of this not very efficiently because we have these kind of very traditional means of organizing scientific knowledge still in papers. Yeah? And I would say that a PDF of a paper or even an HTML page representing the content of a paper is merely a pseudo-digitized version of the analog artifact. So in addition to that, we see also a flood of publications. So there are actually more than 200 million publications out there every year. More than 3 million are published, and some researchers claim that a large part of this scientific literature is not cited, which raises the question of the contributions they made. Also, we have the reproducibility crisis with a large part of research not being reproducible. And we now have a lot of attention to research data, but we need to be also very careful so that we not end up with a data swamp instead of a nicely organized data lake, because we, for example, have not sufficient user integration or insufficient automation. We need to improve the explainability of research data and many other aspects. The flood of publications is illustrated here on that slide. Is also already a few years old, and we find, like now, a few weeks ago, I found more than 1 million results when you search for the genome editing method CRISPR or CRISPR-Cas. And then if you have specific questions, you are really lost in this information. And that's why we work at TIB and also in the NFDI initiatives we are involved in on implementing a vision which Vannevar Bush had already long ago, shortly after World War II. And I would say at that time, he described that in this article as we may think, this idea of a MEMEX, of a memory extender, like a magic desk, which at your fingertips shows all the information and materials on any subject which you need for research. I would say at that time it was pretty esoteric, but meanwhile, we can actually really realize such a system. And what we are working on is the open research knowledge graph. And there the idea is to really represent the concepts, the research problems, the definitions, the approaches, the methods, also different artifacts in different domains in such a knowledge graph. And maybe I show you how this actually works. And I switch to my browser here. And we started developing the Open Research Knowledge Graph more than 5 years ago. And maybe before I show you the classic ORKG, as we call it, I want to show you something which we recently developed, because we also saw that developing such a knowledge graph from scratch is quite, or even for a certain domain, is quite a challenging task. And we need an easier entrance barrier to this knowledge, or to create a knowledge graph. And we developed last year this system called ORKG Ask, where you can ask questions. And they will be evaluated according to the literature. So we have here 76 million items with abstracts, so papers, publications indexed in a vector database. And now you can ask different types or any question against this corpus of literature. For example, I'm taking just the first one here. How does the availability of green spaces impact community health and well-being? Yeah, this might be a research question. And then we retrieve the most relevant papers from this corpus of 76 million articles down here. And we use then a language model to summarize an answer from the literature. So, and this implements this RAG approach, retrieval augmented generation. We also see on top a warning that there might be errors, of course, since we use a language model. We use here Mistral as a language model. And also that the corpus, of course, is only what is freely available, these 76 million articles. Overall, there are more than 200 million. So important information might actually be missing. We also work on that, how we can solve this problem of indexing more also of the licensed publications in Ask, but this is something you should be aware of. Yeah, and then basically here the answer is generated based and then with references to the publications, and then you can scroll down, you see the publications, you have the DOIs here, or if there is a PDF available, you can directly click on the PDF link and the paper will open, and then you can verify and validate the information basically which was here presented to you. So in addition, we try to extract also the answer from the individual papers and also insights, summary, conclusions, results, the methods which are used here, and sometimes, yeah, if you're not happy with something which was extracted, you can actually also regenerate the content for reproducibility. We have here this reproducibility menu, which allows you to look at the prompt, for example, and the parameters, and you can see exactly how the information was retrieved. So maybe I regenerate here the content. And then the language model basically is triggered again and recreates this part of the information. So you can also bookmark the things or cite the information in different formats. You can also extract additional information. So the columns we have here are listed, and for example, we could say types of green spaces, some additional extraction. And when I enter this, the language model will run again and try to extract this information I'm asking for from these papers. I don't know, it doesn't make so much sense here maybe, but here in the first paper, just urban green spaces are mentioned, but in the second one, you also have, for example, agricultural land, urban farms, water bodies, wetlands, and so on and so forth. Yeah. And that allows you to, in a domain-specific, user-driven way, to extract further information from this corpus of literature. And then on the left-hand side here, you can also filter by years, by language. We also plan to add different collections. Currently, we only have one additional collection, which is the research reports. on autonomic driving, but we plan to add more different collections so that you can basically define what corpus you want to operate on. And then we also have information like the citation count, for example, and you could check here for papers which are cited more than 10 times. And if you add this filter, then you will get a different response from the basically now from papers which are cited at least 10 times. So, and what you see here is already also an extraction of structured information from this literature. And in the Open Research Knowledge Graph, we actually take this a step further. So the idea is also that this extraction, which is a bit like a tabular representation of the content from the papers, can then be stored and validated and published in the Open Research Knowledge Graph. And now I would like to show you how the Open Research Knowledge Graph works. So there you can also go into different domains in arts and humanities, engineering, life sciences, and so on. Let's maybe look in the engineering domain. And what we have there is we have subfields, not only papers, but we have these kind of comparisons. And these comparisons provide an overview on the state of the art in a certain domain. And I would like to check, for example, here these studies on energy, Germany's energy supply. So if we open this comparison, we then have also a tabular overview of articles. The table here is actually transposed. Yeah, so here we now have the publications in the columns, not as in Ask in the rows. And then for each of the publications, we have then important information represented here as research data. So these are all studies on the energy supply in 2050. That's when we want to become carbon neutral. And each of these studies, overall, there are, I think, 25 studies, 25 contributions, which we have added here to this comparison. And they are then described in a very domain-specific way. For example, about the energy transformation, it's important what kind of energy sources are considered, what kind of scenarios are envisioned. For example, some assume 100% CO2 reduction, while others only a 95% reduction. And so on and so forth. So for each of these publications, we basically have a structured representation of the main contributions in a very domain-specific way. And although this looks like a table here, like a spreadsheet, it's actually just a view of a more comprehensive knowledge representation in the knowledge graph. And you can actually also look at this if you go here in the Actions menu on View Graph. It will actually show you the underlying graph structure. So, but yeah, so here you basically have you can then zoom in and zoom out and also filter by different aspects. But I find the graph view a bit confusing since it's too many nodes and edges. And that's why this tabular visualization is more intuitive. And you could also then, based on this, since we have now a machine-readable form of the knowledge in the papers, we can also visualize it and create different kinds of visualizations. And here, for example, here you have a visualization illustrated the reported installed capacity according to different of these energy sources in the different studies, and you can quickly see the differences between the different studies in the installed capacity. So, and that gives you a condensed, basically, view of the information. We can also click on one of these publications here and then actually see how the information is represented, and that's exactly this formal representation in the knowledge graph. So we have a subject, we have predicates and objects. So the subject here is the contribution, or different contributions, and then we have predicates like installed capacity, the unit, the values, and represented information in this way here. So that's how you can see that. And we can also see that you can actually edit the content. So if you click on edit, there is an editor, and we can add another property here. You can also click on the light bulb, and that's actually where AI suggests additional properties based on the paper content. So here, for example, has solution, has a research method, has impact, and so on and so forth is suggested. Maybe I'm just adding a new one. I could add now a property. I can start typing something as location, for example. And while I'm typing, it searches in the background in the knowledge graph and suggests me existing properties which are already defined. I can select one and then add a value, and in a similar way, I can type, and what you can see here is that we not only look in the ORKG itself, but also in other sources like Wikidata, GeoNames, and you configure and select also the sources you want to look at. And we also plan to add more domain-specific sources. For example, you could add Germany from GeoNames here. And then you see that it's directly linked, and this is a DC location. And if we click on the link, then we get actually information also from GeoNames and from like the geo coordinates, for example. So I can go back. Maybe I delete the statement which I just added here because doesn't make so much sense. You can also see the timeline, who has updated which information when. So it works a little bit like a wiki. And all these colored buttons here allow then also integrated some AI features where you can then for example, here annotate an abstract. So here you have the abstract of the study, and then it already indicates certain entities which are mentioned here, like research problem, materials, methods. This probably is not correct here, store and go, and you could then directly click on the corresponding entities and also change that. So this is the open research knowledge graph, and there are many more features in the open research knowledge graph. You can also write review articles based on the content in the open research knowledge graph. Let's maybe choose something here. So there you basically can write really text, but then you integrate these kind of structured information like these comparisons, for example, into such an article. And maybe we can also load, show quickly another example. So we had also examples about language models, or here we have something deep learning methods for fake news detection and the comparison. And here you see that the table looks very different. We still have in the columns the publications, but now in the rows we have a completely different description of the research contributions. Like here in that sense, research aim and the goal. and here also the deep learning model, which was used in this particular fake news detection approach, or the data pre-processing methods which were used, the evaluation metrics, the amount of training data, and so on and so forth. Yeah, so each of these kind of comparisons can be designed exactly in a way as the researchers would like to organize the information. We also have benchmarks, and that's maybe also interesting to show. And this is something which is relevant for empirical science. For example, we have particularly here applied it to the data from papers with code, where we have a lot of algorithms and information about algorithms like image classification, for example, is one research problem. And then we have different benchmarks like ImageNet, CFAR, and so on. We can select one of the benchmarks, and then we basically will see a leaderboard of the different approaches tackling this research problem according to this benchmark, and we can see how they perform also over time here on this leaderboard. And you can basically select then the different research problems you can evaluate in this benchmark, and also different metrics. For example, let's take top 5 accuracy, and then we see really here how there is an improvement over time. And on the button, we then have the link to the papers and the respective code as well, and information. Yeah, so this was in a nutshell an overview of the ORKG and ORKG Ask, and that's what we are working on in in using AI for organizing research knowledge. And of course, we would like to make the ORKG also like a crystallization point for more description of reproducibility information for research articles. And now, since I've shown this as a live demo, I can skip these slides. Also, the idea, of course, is that it's not an isolated knowledge graph, but really linked with many other information sources and other knowledge graphs like Wikidata, GeoNames, which I've shown you in this example, but also terminology service, where we have domain-specific ontologies, altmetrics, Crossref, DataCite, and so on and so forth. And the Ask feature for searching literature, and maybe as a first step for creating these kind of comparisons, helps to explore a large amount of information. And I would like to show you quickly here the architecture of Ask. We have these 76 million full text articles where you can ask the question against, and we evaluate these based on embeddings which are generated for all these articles and also for the question. And then based on a similarity search, cosine similarity, we can retrieve the most relevant documents from the vector database, and then using the language model to create an answer based on the context and a prompt for answering this question, and then also for extracting individual aspects from these different papers. And that we see a bit also as a first step in the future of generating these kind of comparisons, that you create these kind of structured overviews by starting with a research question, selecting the literature, extracting information from the literature, but then also manually validating and curating the information. Yeah, and Ask uses basically two prompts, one for extracting the properties from the papers, and the second one for creating these kind of synthesizing the answer from these different papers. And now, what is our next step? What do we want to focus as a next step? So the OKG and Ask, they primarily support the organization of related literature, yeah, or of analyzing the state of the art. But we are now working on an AI assistant which supports the whole research life cycle. And if we look at the research life cycle, we have in the beginning the ideation, coming up with ideas, then retrieving research questions from these ideas, analyzing the literature, but then also developing a method to address this research question, which maybe addresses some shortcomings or gaps in the literature. Then implementing the method, yeah, which might, in computer science, for example, mean to develop some code, but in other areas to design, for example, an experiment or a certain synthesis, and so on and so forth. Then also implementing the method and realizing that, analyzing the results of the evaluation, for example, of the approach, and then writing a paper, also peer reviewing, publishing it. So these are all different steps, and we want to basically support this whole life cycle with such an AI-based assistant system. And we developed already a first prototype. Hopefully, in the next months, we can then release an alpha version of this AI assistant, which really implements this idea of an agentic AI system, because it's not just using a language model. Of course, the language model will be a core part, like a little bit the brain of this assistant. But the assistant will only become to life through the use of these agents and tools and services. For example, in computer science or also in other areas, writing Jupyter Python scripts and a Jupyter notebook for implementing a method, maybe accessing certain APIs. So we already now implemented it that it uses, for example, ORCID and publication databases to retrieve relevant literature, also retrieve for a certain author or person who uses the AI assistant the previous papers the person has written, in order to make very personalized and context-specific suggestions for the research ideas and research questions to tackle. And you can interact with this AI assistant here in such a conversational interface, yeah, where you type a message and then you get suggestions. You can use different kind of sources and different APIs, and you create different artifacts, or we call these assets, like in the end the paper, but on the way also the implementation, the software, source code implementation, maybe also data sets, which you either use from existing repositories, and there the NFDI services and repositories can play an important role, or also other APIs and services to facilitate the research life cycle and process. Yeah, so this is what we are working in. Of course, there are many people involved here. So we have a number of postdocs, group leaders. We have a team on community management, a number of PhD students who work on different aspects of the Open Research Knowledge Graph, or KG Ask, or now also of this AI assistant. For example, we now tackled the ideation stage and are working already on how to generate ideas for new research. And then there's also a team of software developers who make sure that it's a sustainable service, and that we have a scalable architecture. Yeah, and with this, I would like to conclude. So I think we really need to reinvent scholarly communication, but also how we organize the artifacts, the data. I think knowledge graphs are perfectly suited to capture research contributions in a structured, semantic way, making them human and machine interpretable. I think neural models alone will not suffice. We really need to integrate it with symbolic representations of the knowledge. Also, the like just the unstructured content of papers is not sufficient, and we can see that in many ways that the quality basically of the information is not sufficient to really have comprehensive AI assistance. And yeah, with the Open Research Knowledge Graph, we work on establishing a registry for research contributions, also for linking this with the underlying research data, and create such a synergistic combination of human, expert, and machine intelligence, which is still a challenge to support in the future, hopefully, the whole life cycle of research with such an AI-based assistant. Yeah, and with this, I end my talk. Thank you very much for your attention, and I'm happy, look forward to the discussion.